Hi there, thanks for joining me for another episode of Draw, Make, and Code. I'm your host, Ed Cavett, and in this episode, instead of just going through code line by line of a program I've already created, I wanted to discuss what are the processes in coming up with some design. The hardest part a lot of times isn't the coding, it's coming up with the idea and having that idea work out to be something meaningful. And if it's not immediately meaningful, what kind of changes can you make to it to make it more interesting? So I wanted to walk through the processes, at least as what I go through as a generative artist, and maybe that can help you plan out your ideas or come up with more ideas to create some challenges and produce some really fascinating generative art. I want to begin by talking about the P5JS website and the examples page. Now, they're called examples, but it really should be called a toolbox. So every one of those examples is a procedure that you can use to create some meaningful output. And you're not limited to just one procedure because of object-oriented programming. You put those procedures together in multiple ways, in ways that they inherit characteristics, and you get this complex, maybe even this convolution of output from all of these different tools. So I wanted to talk about the process in particular with a program that I created. I'll show you that at the end, but it was actually multiple processes getting to this point. So usually what I do is I'll practice one tool and get that down pretty solid and see what its ranges of output are and what I could use it for in other ways. And then I'll learn some other procedure and keep doing that until I get a really solid toolbox. And then I can start putting those things together. So here you have a particle system, that's one tool. You have a recursion for the leg movements, that's another tool. You have an oscillator movement, that's a third tool. And then you're doing some color conditions and stuff, which you could think of that as another tool. So there's like 4 tools, 5 tools in there, all working together. And they're simple tools on their own, but you put them all together in a thoughtful way, in a very deliberate way, and you can get something really startling. And then you can start changing things a little bit. So here they're just objects moving up and down, but what if I wanted to change the movements of those objects? Or what if I wanted to change the shape of those objects? And another thing to think of is this is a meaningful, really meaningful object. It's a spider. We know what it is, and our brain is carrying that idea. But imagine if you could persist the output, maybe rotate things around, and you're no longer looking at it as a spider, but you're looking at it as more of a brush, and it's laying down some pattern in some meaningful way. So there's ways that you can use a deliberate object like a spider as a generative object, like a spider-shaped brush. In this example, I'm using the same particle system, I'm using the same object. Its motions have kind of changed a little bit in terms of the leg movements, but the body positions, how they're moving around the canvas, that's really changed. They're no longer moving by an oscillator, now they're moving through targeted linear interpolation, and that's a couple tools on their own. So learning the examples, getting those down, and seeing how you can mix those together is going to be really helpful in creating generative art that's very deliberate. If you're interested in making a spider procedurally, I have a video that will show you how to do that line for line right here. So if you're familiar with the examples from the P5JS tools page, as I want to call it, then you are aware of the flocking behavior algorithm. Well, the spider is kind of a bird. Just change it a little bit, you get a bird out of it, and set it to the flocking algorithm and you get this output. If you set it to the targeted linear interpolation and then rotate the canvas and persist the output, you get this. So this steps away from it being just birds, and now it's looking like something else. I'm not even sure what, but it is pretty cool output. And as far as a generative form, you could take a snapshot of any one of these frames and have some really meaningful output. So I went from a complex of different procedures that was creating something very deliberate and very specifically meaningful, and now I've went to something that's meaningful, but it's an abstraction of whatever that specifically meaningful thing was. And I think that's a really fascinating part of art in itself, and a fascinating aspect of generative art that you can do this. And the background for this output, the changing of the color, that's done through sine waves associated to different channels of RGB. So there you have another procedural system that's working to enhance the output. So next up, I wanted to talk about circle packing and those procedures, and how it can arrange objects of different scales on a canvas without them overlapping. And this gives us a lot of advantages in terms of generative output. You can see here there are some flower looking objects, so wherever you might have a circle in the circle packing procedure, you have now an object that treats that little region like a canvas in itself. So if you have some procedures that you print just one of those on the entire canvas, imagine taking those procedures that apply to the entire canvas and applying it now to an imaginary canvas of any dimension. And then you can put those imaginary canvases on a real canvas in a circle packing way where they don't overlap, of different scales, and then put your output inside one of those little canvases. And this is what you would have. Now, because of the distribution that you get from circle packing, it's meaningful for a little bit, but then it gets kind of boring. So what you can do is layer. So you're running the procedure, you're creating one instance of the circles being distributed, and then you're running the output, and then you go and reset everything and create another instance of it being arranged in a different way. And you layer that on top, reduce the output of the previous layers, so that every time you get a new layer, it's erasing some of the previous output, so things never build up past a meaningful way. In generative art, you can oversaturate your work, and you're running the procedures again and again where everything just kind of melds and blobs together. And that's one of the things that you kind of want to avoid in long-form generative art, because it reduces the amount of meaningful output that you get. In generative art, you can have two major goals. You can have the one for producing static output, like a poster or an image file, or you could have the goal of creating some animation or some video, maybe even audio associated with it, or just audio, so it's not like a static thing, it's changing over time. So if your goal is to create some static image, then your thoughtfulness in designing the procedures are going to be a little bit different. If you're wanting to create something that will run for a really long time and will still remain meaningful, well, then you have to think ahead. You have to be aware of your limitations. How are you going to take away the output so that it doesn't become oversaturated? And this could be as simple as just starting over or doing the layers like I do in these procedures here. And that seems to be one of the aesthetically pleasing ways to do it, is just to slowly diminish the output that's already been laid down as you're putting new output. If you just start over, that start change can be a little disruptive. So if you're trying to maintain some continuity, then maybe diminishing the output by using some alpha on the background every frame, and it could be just a really small amount of background clearing, but over layer after layer, it really does have a huge effect. So play around with that if your goal is to have some animation that remains persistent and it doesn't have that really stark disruptive change in the reset. And this final thing before I go in this video, I wanted to explain the procedures that are specific to this generative system here. Like I said before, it's a circle packing algorithm, so I'm making these little canvases, and inside those little canvases I'm generating some output. And this is tied to a circle. Now, I'm not just drawing a circle using the circle graphics keyword, I'm drawing a circle using cosine and sine, so the actual math. And this gives me a little bit more control over the coordinates. So when I put objects that are associated with a circle's perimeter, I can rotate things and still know where I'm at. So I'm very specific about doing it that way. I tried doing it the other way using rotations and translations, and you just kind of lose track of things. And when you're drawing lines, that can that can play a huge role in the output. And I was running into a problem where the lines weren't connecting to one another because they were offset by the rotations, and it was subtracting that out, and it was just getting too complicated. So I'm like, you know what, let's just tie this to the actual perimeter values of a circle, and then that gives you a lot more control. So the point of that is, don't always rely on the keyword methods that are built into programming. Understand what the processes are behind one of those keywords in case you have to do something very specifically. So you can rely on the keywords if it's general, but if you need the perimeter points of the circle, and instead of just drawing a circle, then it's important to know how to make a circle. It's important to know how to make random numbers or pseudo-random numbers. In the case of computer coding, it's really hard to make real random numbers, but you could have systems that make real random or pseudo-random numbers that don't rely on the keyword. So understanding those procedures, it's not critical to coding, but it will give you a huge advantage in improving your ability to use that toolkit. You get, well, far more control over things. You also notice in my coding that I don't follow the standard methodology that's commonly taught in school. I have some formal training in JavaScript, and I have some formal training in some other coding languages that require that you make a flow chart and do all of that in advance stuff. But as a hobby codist and as a generative artist, I just have a style that I'm comfortable with, that works well with my brain. And if I try to force it into some methodology, some academic methodology, then I feel like I'm losing some freedom. Eventually, over time, I'll converge on that methodology, but it has to be in my own time, in my own way, or else the concepts aren't crystallized and I'm just wasting my time. So if you're kind of like that, then I would encourage you to just code as you feel. Even if it's redundant, even if you're duplicating things, you can always optimize later. The point is coding in a way that you understand what's going on. And if it gets too procedural, you can lose track of what's exactly happening. And then it gets harder to track where you need to change things or what you need to fix. So do it the way that it makes that's comfortable for you. Do it in a way that it makes sense to your brain, and don't be pressured into having to code exactly this way, having to code exactly that way. Unless you're going to work for Microsoft or Google or something like that, a tech company, then it's important, because others are going to be using your work and they need to know what you're doing. But if you're a generative artist, chances are most people aren't going to see your work in terms of code. If they do, they're on the same page as you anyway, and they're just looking at the pieces. Maybe you can explain it to them or whatever. But the point is, that code is for you to make art. It's not there for a Fortune 500 company to train other people to use. It's for you. So make it for you, make it comfortable for you. In the last few seconds of this video, I want you to hear, maybe in the background, all the noise that I have to work through to do the narrations, and it's really challenging. So I hope you enjoy the work that I've put into this, if you can hear me right now. If you can, leave me a thumbs up, subscribe if you haven't. If you have subscribed, thank you so much, and as always, until next time, take care.